Now we're going to talk about vector multiplication, but we're going to be multiplying a vector by a scalar. So let's do vector times scalars. So that is what the focus of the video on today is, multiplying vectors by scalars. So let's say we have in green, a nice green color, we have vector b. Let's say vector b is equal to some scalar. So we'll just write in brackets like a scalar. Remember, a scalar is anything with just a magnitude. We can, for example, we can say mass is a scalar, speed is a scalar, stuff like that. Scalar times a vector. And this is things like velocity, acceleration. What else? We can say force is also a vector. These things are all vectors. And whenever we're talking about multiplying a vector by a scalar, we're really just talking about different multiples of that vector. And that idea can be kind of confusing, so I'm going to draw this out. So let's say we have this vector. Let's call it, generic vector v. Now let's say we want to multiply vector v. Let's say we want to multiply it by 2. So whatever scalar this is, we're going to multiply it by 2. Vector v is going to be twice as long. So this is going to be 2 times vector v. Vector v is going to be twice as long as the original vector. So vector v times 2, or 2 vector v, is going to be twice as long as vector v. So what I mean by this is, so let's say that, so now we're saying let v equal vector, and let's say let k equal scalar. Therefore, we can say that multiplying k times vector v, that's going to be a vector. So this is a vector. So it's still a vector. So multiplying a vector by a scalar still results in a vector. And it is exactly k times longer. So when we multiply a vector by a scalar, it is going to be the magnitude of that scalar times longer than the original vector v. So that's kind of the rule. Okay, now, as we saw here, when that scalar is positive, so we can see here the scalar is positive, we can write a little plus in front of it, the direction stays the same. So we can make that a rule, right? So when k, so remember we use k to represent a scalar, so when k is greater than 0, direction doesn't change. Now, what would happen if vector v here was multiplied by -1? Well, something like this would happen. If it was multiplied by -1, so here's -1 times vector v, it would have the exact same magnitude. So, this and this have the same magnitude, they have the same length, but they're facing in opposite directions. So we can say that when a scalar k is less than 0, so it's negative, the direction changes, or the direction more specifically is opposite. So not only does the direction change, but it becomes the complete opposite. So I hope this makes sense. So whenever we multiply a vector by a scalar, the result is still a vector, but it is going to be a multiple of that vector. So it's going to be a certain amount larger or smaller, right? And we show that here. So when k is multiplied by a vector, the vector is equal to the magnitude of k times vector v. So that's exactly how it's going to work. And if k is negative, then the direction becomes opposite.